Through the night of combat danger, this heart of power, the three engines of a patrol torpedo boat, could never stop. The lives of a crew of Americans depended on them. Facing an armored world with nothing but speed, the PT boat made a bet every time it roared into action. Bet you 10 lives I can get in, blast you, and get away before you can touch me. The Army rescue boat of the Air Forces raced against time, the seconds in which a downed plane sank, or the minutes it took to freeze a flyer in winter oceans. The Warhawk carried a single pursuit pilot who put his trust in it. British flyers swore by their Hurricane, nicknamed Can Opener, when its 40mm guns ripped open Nazi tanks in Africa. Members of Lancaster crews learned that engine failure on a deep penetration of Germany was the least of their worries. Fastest of bombers, the Mosquito made the Berlin run on speed alone. All planes returned safely was the communique celebrating their nightly triumphs. The Mustang, fastest of the fighters before jet planes went to work, climbed higher too. It wasn't as big as some, and it couldn't cook, but flyers fell in love with it. You can hear them snarling away up there and feel the hard courage. They can dive 40,000 feet and not get heart failure. Want to look at a heart like that? The power inside all 5 planes? There she be, the Packard version of the Rolls-Royce engine sitting on the test block, pretty as a picture. Strong as 1,500 horses, equal to the weight of one. Want to see the heart of an Elco PT boat, mighty midget of the U.S. Navy? Or of an Army Air Force rescue boat? This is the Packard Marine engine. It is a 60-degree V-12 aircraft type water-cooled supercharged engine of 1,500 horsepower. The boys on a PT boat housing 3 of these say it'd fly if they opened the hatches. These engines have a home, the giant rooms of the Packard factories. They come into first being in the pouring hot metal of the foundry. The clangor of the forge is their birth cry. They are shaped in an intricately organized jungle of machinery, formed on the varied devices typical of the industrial might of America. Thousands of machines. The intimate touch is not lacking when a profilometer measures a skin or surface texture in millionths of an inch. These engines have parents, tens of thousands of them working around the clock, day and night. Young and middle-aged. War vet James Thornborough, invalided from the African campaign. And a war bride with a husband who saw action. And newcomer Steve Sorovsky, who still needs a guide to show him what to do and how. Here's Steve Komisiak, who's been with Packard 41 years. These engines have ancestors, a pride of ancestry, and a history dating from the early days. It was 30 years ago in 1915 at the beginning of another war. A new world was bursting in upon a civilization that seems quaint to us now. Autos still remembered they had once been buggies. And the directors of a young auto company, Packard, looking farther ahead than they knew, decided to set aside $250,000 for the development of an aircraft engine. Here in the Packard Hall of Fame is what they came up with. Old 299, named from the cubic inches of its piston displacement. Since there were no facilities at that time for testing an engine in a plane, the famous auto racer, Ralph De Palma, was hired to see what it could do on the ground. It could do plenty. It could win 5 races in one afternoon in 1916 at Sheepshead Bay and establish records in each. Satisfied those principles were correct, an engine 3 times as big, the 905, was made. It broke the world's mile record at 149.4 miles per hour and ran 20 miles, averaging 134 miles per hour. Out of that engine, 905, came the Liberty motor of World War I, co-designed and built in volume by Packard. Then we were asked to build the engines for the Navy's first dirigible. They had to be able to run 300 hours without an overhaul instead of 50, the former requirement. The Shenandoah was bent on seeing the world with no stopovers for tinkering. We made a lot of engines in those years. Engine 1500, which normally ran upside down, powered Boeing 66, world's fastest standard fighting ship. We built the first engine designed specifically for a tank. Before 1924, any engine strong enough and sturdy would do for a tank. That same year, a Navy PN-9 with two 600-horsepower Packards set 7 world and 20 American records. The next year, one of them flew to Honolulu, 1,841 miles, which was another record. In 1926, we wound up and delivered our 24-cylinder X engine, the most powerful in the world. Just then, an air-cooled engine took over American aviation. What's the difference? If nobody wants a liquid-cooled inline engine in the air, put it in the water and make a clean sweep of speedboat racing for a decade. The Gold Cup, the sweepstakes, and the Harmsworth races were by way of becoming the private preserve of Packard power. We were learning how close an engine can come to making a wingless boat fly. Miss America 10 set a world's record of 124.9 miles per hour. And that's about where matters stood when the World's Fair opened in Flushing Meadow. The world was at peace. At least we were permitted to think so for a little longer. The evening fireworks were very popular. Aerial torpedoes exploded so loudly you could actually feel a slight concussion. But the Navy was already working on an idea they called a patrol torpedo boat. It was a speedboat for fighting. And when the Navy called for an engine to put in this boat, Packard was first in line. It was more than 2 years before Pearl Harbor. Navy orders 7 Packard Marine engines. 7 months later, Navy orders 81 Packard Marine engines. 1 year to go to Pearl Harbor. Navy orders 720 Packard Marine engines. 5 months to go. U.S. Navy and Great Britain order 900 more Packard Marine engines. This was only Packard's pre-war beginning. Here comes a mighty battle wagon with a strange burden. The Rolls-Royce engine, with a blanket permission to manufacture, was being brought to the United States with maximum safety. Not content with one such problem of its own making, Packard in the summer of 1940 rushed in where others feared to tread. Only Packard thought this hand-fitted job of more than 14,000 parts could be mass-produced. Like the Marine engine, this baby has a history. It goes back to the first Rolls-Royce aircraft engine for World War I, 25 years ago. It goes back to the power plant of a slim racer, the British Snyder Cup entrant of 1931. This was the engine that beat the Luftwaffe against terrible odds. On September 2nd, 1940, 700 German planes rained fire, death, and destruction on London. The following day, Packard signed a contract to deliver 6,000 engines to Great Britain. The next week, a contract for thousands more was signed with the United States. How do you do it? How does Packard turn out 50, 60, 70,000 of these fantastically complicated engines, marine and air, in the following war years? You grow. You're a mile long to begin with. You grow fast. Ground was broken for this engineering and assembling a month before the architects finished their plans. 78 test cells invite 78 roaring engines to run their 6-hour tests simultaneously. Another mushroom of the so-called 10-month miracle of construction was the tear-down and reassembly building. The heat treat building was 4th of the new structures rushed to completion for the Rolls-Royce assignment. When the production ante had been upped a few more times, this new $5 million Toledo war plant was taken over to continue the expansion. Then Packard funds bought another Detroit plant 3 miles away. It added 150,000 more square feet of manufacturing space. And across the railroad tracks, a matter of blocks away, more space was rented in a Milwaukee Avenue plant. But the new plants were not enough. Auto manufacturing machinery moved out. Almost none of them could be used. They waited in their skins of grease undercoverings for some future day. Meanwhile, Packard engineers were working round the clock, redrawing to American production needs more than 2,000 English left-handed blueprints. Additional thousands of jigs and fixtures were specified for the gigantic shop task ahead. Then were installed the giant, medium, and midget machines of mass production. Here's the 48 spindle Bosch, reaming its 48 holes with a single operation. The drill presses make holes as fine as the point of a needle through metal hard enough to withstand the shock of an explosion. Yes, they're women. At that time, almost half the Packard payroll was women. Before the war, they didn't number 1 in 10. They were another part of our answer to the incredible expansion. A woman's light touch has helped in the inspection of parts so delicate they must be handled in tissue paper. A drop of acid perspiration can etch and eventually crack a piece of metal. When a few 100,000 machines, gauges, and instruments had done their jobs, the parts flowed into the main assembly line. 10,000 parts for a Packard marine engine, 14,000 for a Rolls-Royce. One engine is enough to make your brain whirl, but here they come like elephants in a circus parade, head to tail. An icebox full of dry ice cools parts before fitting into place. When warm, they expand to a tighter than perfect fit. The line moves too fast for one huge factory to supply all its parts. Some are farmed out to smaller shops and factories. The exhaust stacks of the test building are visible proof of the careful check being made inside. For it's never enough to just make this engine. You can't be content because it runs. Will each one keep on running under the stress and strain of battle action? The answer lies in arduous open throttle tests. So put gauges to its vitals, run it under its own power for 6 hours and see. Then after this dynamometer test, every engine is taken apart, washed, cleaned, inspected, and put together again. The U-shaped tear-down and reassembly line on and within which all this happens is another one of the Packard firsts. To the layman, all seems confusion, but actually every move is purposeful, thought out to that ultimate efficiency necessary for the handling of such a complex machine in mass production. When an engine has been brought to that kind of condition, off again, on again twice, the least you can do is protect it. Wrap it up in super cellophane. Pack it in a vacuum with moisture-controlling crystals, because that engine deserves the best. Ready to go, it rests in a weatherproof box, and our job is done. That's what we thought when the bottom was kicked out of the world Americans were trying to live in. Men went to war, labor was hard to get, war materials grew scarce, and we were asked to increase our production of marine engines threefold. Only 47 engines in the Rolls-Royce contract had been completed of the thousands to come. More space, more employees, more women at work, and improved mass production helped, but never enough. Our management labor work to win campaign, conceived a month after Pearl Harbor, attacked the problem from inspirational, educational, and competitive angles. Its most successful outcome was the suggestion box. Employees of all departments could do their bits toward improving production. In a little over 2 years, Packard's people made 31,331 suggestions, over half of a mechanical nature. Some 5,000 were put into effect in the shops. Fred Ospedale, an aircraft engine assembler and gang leader, was invited to the White House to be honored for his innovations. Awards were given by the War Production Board to 156 Packard employees for production shortcuts useful on a national scale. Tens of thousands of Packard workers put their minds to cutting engine cost and the taxpayer's bill. Pooled together, the sum total of production spirit was greater than the individual contributions. It all adds up to nearly 70,000 engines for hot airplanes like this, for mighty midgets like these. We have the deep satisfaction of knowing that no builder, such as Elco at Bayonne, who turned out the greatest share of the Navy's PT craft, ever had to wait for an engine. And 3 of our marine engines go into a single PT boat. Lieutenant Commander A.R. Montgomery, commanding officer of a torpedo boat squadron, said, "It is an inspiration to see where the Packard marine engines are built. And it is mighty reassuring to know you're backed by these engines when in action against the enemy." Lieutenant Commander John D. Bulkley of They Were Expendable fame told how his PT boat engines in the Philippines and off New Guinea did 4 times the service normally expected of them. He said to a Packard group, "Your work has helped save my life and that of my crew many times. If the engines had failed us during any critical moments while at close quarters with the Japs, I wouldn't be here today." With Bulkley, as with all others in the PT boats, the one requisite was speed, and what went with it, dependability. The boat skimmed the water like a seaplane taking off. They bounced from wave top to wave top. They dodged attacking planes. They played tag with enemy gunfire in a game that was for keeps. Can you imagine the men in those boats failing to feel gratitude for the power that helped them win their bets against death? As it was with the marine engines, so with the Packard version of the Rolls-Royce. It reminds us of the thousands of precautions we lavish on our engines to guarantee that they're perfect and will remain so under the most difficult conditions. This Magnaflux ferrets out metallic flaws invisible to the naked eye. The oscillograph uses electric waves to test for balance and freedom from the vibrations that increase dangerously with wear. New bearing materials of silver, lead, and indium have taught the engineers how to increase the lifespan of engines, be they air, water, or ground. Most spectacular of the many new heat-treating methods which burn greater endurance into materials is the night riding oven. These and many other processes, inventions, and refinements helped fill in the great panorama of Packard at war. They spell better product, longer life, lighter, stronger, more powerful, and more efficient. This means we will be able to give you more for your money. These efforts foretell an auto of the future that will be benefited in every respect. Any young pilot or PT man wanting a post-war Packard because his service taught him to doesn't have to depend on that alone. He could ask one of the people who own a Packard Clipper bought before the war and still going strong. Their endurance is a guarantee of the continuity of the Packard effort. But the young man doesn't need to ask. When a man or machine is battle-tested, that's final. When men have bet their lives and won on Packard-built engines, it's not luck. It's a habit. It's the habit of precision manufacture, too strong to break down come war or mass production. It's the teamwork of Packard people who stand shoulder to shoulder for the best in war or in peace.